Hello everyone. We're going to begin learning about global and local winds. There will be additional YouTube videos for you to watch and learn more. So first we need to understand what air movement is. Okay? Now air movement is basically wind. And wind is the movement of air caused by differences in air pressure. You remember air pressure. Air pressure is basically the intensity or the weight of air molecules pressing down on you. Okay? The greater the difference, the faster the wind moves. Okay? So the differences in air pressure occurs due to the heating of the earth. Okay? Whether that heating occurs from radiation, conduction, or even convection currents. Okay? Remember those definitions of those three types of energy transfer that we talked about earlier. Uneven heating produces something that we call pressure belts. These pressure belts occur every 30 degrees latitude. Do you remember what the latitude lines are? The latitude lines are the horizontal lines that we put on a map or globe. Okay, so here's a picture of our polar belts. Okay? Notice that each belt occurs along the 30-degree latitude lines. At the top, we have the polar belts. Towards the middle, we have these Hadley belts. And we'll talk about these more as we continue. You can always go back in this video or reference this PowerPoint in the files on Canvas. So let's look at this picture of pressure belts. As warm air rises at the equator and moves towards the poles, it cools, just like those convection belts. As it cools, what happens to air? As air cools, it becomes heavy, so it begins to sink. These cool air belts will sink around the 30-degree north and south latitude lines of the equator. Notice how the polar belts sink. Look at the arrows. Notice the blue arrows. Okay, these pressure belts. At the poles, the cold air sinks and moves towards the equator. Around the 60-degree north and south, the air begins to heat up. Now, this is at the equator where the sun beats down on the earth directly. What happens to the hot air in a room? It rises. The same occurs on the earth's surface. Hot air rises and cold air sinks. This movement of air causes these pressure belts and results in these global winds. Now, a little bit later, we're going to have a lesson on the Coriolis effect. So just to give you a little bit of a heads up as to what the Coriolis effect is, I want to talk to you a little bit about it now. So the Coriolis effect causes wind flowing from a high pressure to a low pressure system to curve as the wind moves. In the northern hemisphere, the Coriolis effect causes things to curve to the right of the observer. Notice the picture at the bottom, or I guess I should say the top picture. Look at how the lines are moving. See how the lines begin to curve? In the southern hemisphere, below the equator, the Coriolis effect causes things to curve to the left of the observer. Notice the lines, the solid lines, and how things move to the left. We will be watching some videos that demonstrate this effect.